Okay, so in this video, I want to go over the algorithm to run a depth first search on a tree. So here we go. We're going to be starting with from our previously defined tree. We ran this, we generated some numbers, we shuffled them up, we made sure that we can add to a tree. So how might we traverse all of the nodes of a tree? Well, there are two main methods. The first one we'll talk about is depth first search, and that depth first here means go down as far as possible to leaf nodes and then climb back up. And in particular, we want to descend, D-E-C-E-N, descend to the left subtree, then the current node, then the right tree, right? So if you think of a tree, we want to go down the left side. At any node, we want to go down the left side as far as we can, get its value, then go back to the parent, get its value, and descend down the right node, right? So at each node, we descend left, then the node's value, and then the right set of nodes from the right subtree, all right? So how can we do this? We will need, of course, a function, binary search tree, DFS, and we'll need a tree out of this, right? Takes a tree. Perfect. So as with almost all recursive data structures, the base case or the ending case is often a list, and we need to return something in the base case, and in that it is almost always the case that we're returning an empty list, right? So as we're descending down our tree, if we get to a node that's empty, in other words, this subtree, either left or right, is empty, then we're done. We don't have anything to add back into the list that we are building up. Okay, make sense? Then if it's not an empty, then we have a normal node, which means we have a left subtree, we have a value, and we have a right. Okay? We'll shape this up. And what do we want to do? Well, let me just build up some parts. We need to, as I mentioned, we need to go down the left first, so we need to descend DFS down the left. Then we need the value, and then we need to descend depth first search down the right node. Okay? So assuming each of these returns a list, we then want to just append them all up. So let's do that. All right. And we will bring up our perfect. Now, in Racket, this is not a valid list. It would be an execution of a function, so we need to build a list out of it. So now the depth first search is build me a list of values with all of the left nodes as far as possible, then the leftmost parent, or the parent of the leftmost node, then all of the right node, again, going left as much as possible, and return all of those to as our list of numbers. Okay, so let's save this, and then we will run it. And we're not printing anything out, but we don't get any fails, so perfect. Let's test this out. And let's test it, as we can see here, on our shuffled tree. That is, in this case, tree 2. So we're going to print F, and we're going to say DFS. We're going to get something back, again, a list, and we want to do a binary search tree, DFS, of tree 2, our shuffled tree. We'll save this and run it, and we get DFS. So we have our shuffled tree. The nodes were 3, 0, 4, and 1. Make sure that's right. 3 is the root node. 4 is to the right, as it ought to be. The next one was 0. 0 has no left. There is, of course, all of the remaining numbers. 1 and 2 are going to be on the right. The next one should be a 1 in our insert order, and then followed by a 2. When you depth first search, when you go left, parent, right, you happen to get all of the values of a tree out in sorted order. So this is one very cool feature of the depth first search, is that the data comes back sorted. So this is the implementation for depth first. We'll go over it one more time. We descend. We need to create a list that has all of the values of the left node, then the node we're on, then all of the values out of the right. It is incredibly simple and incredibly cool algorithm that returns our data in sorted order. And that actually is it for this particular video. Thanks.